All right, so we're going to go over a bit more of the notes on function notation, function arithmetic. One thing that you should know is for writing that when I am writing, fxn is just short for function. It's a lot less to write, a lot less to type, and it fits in the boxes a little bit better. All right, so function notation, remember functions are rules. We can't solve a function, but we can simplify functions. If we want to solve an equation, we'd need to have just variables, and that's where we replace the y with f of x. That they're equal or equivalent. They represent each other. So for our first thing that we're doing, we're rewriting 2x squared minus 5x plus 3 in function notation. All we have to do is pick which letter we want. We want to call it function f, g, or h, or any other letter that we like. I'm going to call this h of x because the variable that I see on the right-hand side is x. So I'm going to say that this is the h rule. And then I just rewrite that expression. So h of x equals 2x squared minus 5x plus 3. So that's in function notation. I could have decided to call it f of x if I wanted instead. All right, so if we are, remember, function notation is going to be our shorthand way of telling us what to do. So if we say f and then we put some number in it, it's going to say, oh, we're not going to look at x's anymore. I want every single x to be replaced with whatever number we have. So if I am doing f of x equals 2x minus 3, and I need to solve for f of 3, I would start by saying f of 3 equals, and remember that 3, it's in parentheses. Let's keep it in parentheses on the right side. So 2 times 3 minus 5. And now I get to simplify it. And doing order of operations, 2 times 3 is 6. And then I still have that minus 5. So f of 3 is just going to equal 1. All right. So then we have some practice for you guys to do. We have our f of x equals 25x plus 8. We're going to do a couple of them here, and then we're going to have the rest show up in the notes, giving you some time to practice them yourself. Now, I'm fairly certain that the ones that you're going to not like the most are the fraction ones. So we're going to hit those with our notes. So f of 7/5, that would equal, I'm just going to leave that as my right side. I'm going to say equals. And then I have 25 times 7/5 because I'm replacing my x plus 8. Now, if with fractions, if everything's a fraction, I can always reduce stuff top and bottom if possible. And 5 goes into both 25 and 5. So 5 goes into 5 once. 5 goes into 25 5 times, so I'm really dividing. And then when I'm multiplying fractions, I get to multiply straight across. So this equals 5 times 7 over 1 times 1. So this is 35 over 1. And then I still have that plus 8. So this is just 35 plus 8, which is 43. So f of 5/7 is 43. Not always are you going to get a nice number with that, but that is perfectly fine. So I'll put my 43 over in the answer box. The next one, the other fraction that we have is f of 4/3. We can do that one the same as we did the 7/5. So we're going to rewrite the problem. So we have 25. And then I'm replacing the x with the 4/3. And then I have a plus 8. So we're going to make that into a fraction. We are going to do the simplifying. In this case, 3 does not go into 25, so I can't reduce it. So in that case, I'm just going to multiply straight across. So 25 times 4 is 100 over 3 plus 8, not equals 8. All right, so this is one fraction, and then I don't have a fraction, so I'm going to make it all into fractions. I am not going to reach for the calculator because they just slow me down. If I'm adding fractions, I need the bottoms to match. So this one needs to become a 3. Whatever you do to the bottom, do to the top. So this is going to become 100 plus 24. Once the bottoms match, I just have the one bottom. So this is going to be 124 over 3. Now, I can check to see if 3 goes into that whole sum, and it doesn't, because 1 plus 2 plus 4 is 7, and 3 doesn't go into 7, so 3 is not going to go into that. I'm going to leave my answer as that improper fraction. So my answer is going to be 124 over 3 equals f of 4/3. And that should have said equals f of 7/5. Okay, so the rest of them, you're going to try them yourself, check your answer with the answer key, and then let me know if there's questions with that. So we're going to go back down. Now, sometimes they're going to say what the function is equal to. And in this case, we're going to be solving for the variable as opposed to evaluating. So we get to first rewrite the function. We're going to put it back into the y equals because we can't solve a function. So we're going to say that f of x equals 4x plus 3, and they want to know what x equals when f of x equals negative 21. So we're going to first write y equals 4x plus 3. And now f of x is 21. So that is the same thing as y. I would probably put this here. So you kind of have to know what different things equal. So this is going to be negative 21 equals 4x plus 3. And then we just get to solve like normal. Try to get the letters on one side, numbers on the other. So I only have that 1x. So I'm going to subtract 3 from both sides. And then I have negative 24 equals 4x. Divide both sides by 4. So you get x equals negative 6. Okay, it's not always going to be a nice number. Sometimes you're going to get left with a fraction. Totally valid. All right, so this time we're going to do some practice ones. I will do, well, it doesn't really matter which one. We will do one of them, leave the other one for you. Both of them should work out decent, so I am going to just do that first one. So I have k of x equals negative 14. You're really solving y equals negative 3x plus 4, and this equals y, so y equals negative 14. So negative 14 equals negative 3x plus 4. Get the x by itself, so we're going to subtract 4 from both sides. So we have a negative and a negative becomes even more negative. So this is negative 18 equals negative 3x. Divide both sides by negative 3. And you have x equals, a negative divided negative is positive, so x equals 6. All right, so we're going to leave the other one. The answer will be put in with the works and steps in the answer key, but try to do it yourself. Take a pause in the video and do that, and then check your answer with the answer key. Now, some of the skills that we're going to do, this has got some arithmetic or algebra, kind of pre-algebra type of review, combining like terms, foiling, that kind of stuff. So we're going to be looking at just some of those skills. So we'll do these 4 problems a little quickly. Now, when we're multiplying 2 binomials, binomials are 2-term things. Terms are always groups of letters or numbers separated by plus or minuses. So this has got 2 terms, the 4x and the plus 3. Those are 2 terms. And then the 5x and the negative 1. Those are both 2-term expressions, which are called binomials. Now, a lot of people are taught to do this with the arrows. We are going to do that as well, but then we can also do it with an area method where we're going to put each polynomial or each binomial on each side of the box. So we're going to do that first. So this is going to be the same thing as 4x plus 3 going this way. And then I have a 5x and a minus 1 going this way. And I'm just going to multiply each box. So 4x times 5x is 20x squared. I should be in a different color. So I'm going to erase that. Change color. I'll do it in pink. So this is 20x squared. 5x times 3 is 15x. Negative 1 times 4x is negative 4x, and negative 1 times 3 is negative 3. Like terms are going to be on the diagonals going acrosswise, so I have negative 4x and 15x is going to be that 11x. So my answer is going to be all these boxes, which is 20x squared plus 11x minus 3. Now, you can still use the arrows. Arrows are perfectly fine. It's whichever way you are used to doing the problems. So if I do the arrows, remember I'm distributing or multiplying everything in the first parenthesis to everything in the second parenthesis. So that 4x times 5x is 20x squared. And then that 4x has to go to that negative 1. So 4x times negative 1 is negative 4x. I am now to the other one. I have to distribute that positive 3. And I usually do it on the second line so that things line up in my my like terms, but they don't have to. I can keep writing to the right of this. But 3 times 5x is 15x, so plus 15x. And 3 times negative 1 is minus 3. Combine my like terms, I have 20x squared plus 11x minus 3. So same answer both ways. Whichever way you're going to get all of the terms and not miss something is totally fine. It's whatever you feel is best for you. Now, when we're combining like terms, we always want our terms to count down with exponents. So we want the biggest exponent first. We'll call that our lead coefficient, and our degree is the highest exponent. There's some other quirks if you have more than one letter, but we're going to pick the exponent that has the highest, the term with the highest exponent first, and that is my x thirds. And we are looking, is there any other one? Nope. So that one is going to be by itself. So 9x to the third. And then we're going to look for the x squareds. So I have a negative 4x squared. I'm going to circle the sign with it. And a negative 8 and a positive 8x squared. Combine those together. So negative 4 plus 8 is going to be a positive. You got to subtract them, and the 8 was bigger. So 8x squared, so it stays positive. And then I have a 19x and a negative 20x. Those two combine, and 19 minus 20 is a negative 1x, or just negative x, your choice. And now I've combined all the like terms. The exponents don't match. I cannot do anything else with this. Now, when we are dealing with exponents, if they're attached to parentheses, there are two sets of the parentheses. In this case, since there's only one term in that parenthesis, I could distribute it. So I could do this problem two different ways. I could call this 9x, there's two of them, and a 9x, and simplify that. So 9 times 9 is 81. X times x is x squared, or 9x times 9x is 81x squared. The other way that I could do this, because there is only one term in here, there's no plus or minuses, I can distribute my exponent, and that would be 9 squared times x squared. 9 squared is 81, and then I just have the x squared. Both ways work. It's whichever way you feel more comfortable with. Just be careful. I can only distribute if there's no pluses or minuses in the parentheses. All right, looking at the next one, there is this negative sign that will change all the signs of everything that follows it in that parentheses, or you can put in your negative 1 and distribute that negative 1 to every single term. Either way is your choice, but we got to get rid of those parentheses. So first thing we're going to get is 3x. And then negative 1 times 5x is negative 5x, or think changing the signs. And negative 1 times positive 3 is negative 3. Combine like terms, which is just that 3x and the minus 5x. So you have negative 2x minus 3. And that is all we can do right now with that. All right, so when we're doing arithmetic with functions, that is, we're telling us what we're going to do. That is the left side of the equation. We're going to replace it with the right side of the function so that we can simplify from there. So when I'm doing f of x plus g of x, I'm going to take the right side of the f of x. I'm going to rewrite that. So this is going to be 2x plus 5. You can put it in brackets if you want. I have the plus sign from the problem, and then I need my g of x, which is going to be my 2x squared minus 3x. And now I'm looking at it. I don't have anything to distribute to either of those parentheses or those brackets, so I can just look at my terms. So 2x plus 5 plus 2x squared minus 3x. That is a minus, not a plus, so I will make it a little neater. Combine like terms. This is an x, not a v. All right, so put them in order. I have x squared first. So positive 2x squared, since there's nothing in front, it'll be 2x squared. And then I have a 2x and a minus 3x, so that is minus 1x, or just minus x. And then I have a plus 5. All right, if I'm subtracting, I definitely need to have those brackets with my problem. So I am going to do h of x, which is 4x. And I've got a minus sign. This is one term, but I'll put it in brackets. F of x, which is 2x plus 5. But remember, all of that is being subtracted, so make sure you put it in brackets so that you remember to distribute or change that every sign to negative. So then we have 4x minus 2x. Negative 1 times 5 is negative 5. That is where things will usually fall apart, is we'll forget to change that last sign. Combining like terms, you have the 4x and the minus 2x are like terms, so you have 2x minus 5. Now, the dot means multiplying, so we are going to multiply the next problem. Yet again, we're going to keep things in brackets. So f of x is 2x plus 5. G of x is 2x squared minus 3x. You can use your arrows, but I'm going to do the area method just because I can. 2x plus 5. I just find it a little quicker. Sometimes it's a little more writing to start with because I have to draw my box, but I find it better. Like I said, you can use the arrows. Just be careful that you do use your arrows and are using like terms. Multiplying 2x squared times 2x is 4x cubed. 2x squared times 5 is 10x squared. 2x times negative 3 is negative 6x squared. And negative 3x times 5 is negative 15x. Now, I do have like terms in those diagonal boxes. So putting my terms in order, I will put it in the darker blue because you can see it better. So I have my 4x cubed. I have 10x squared minus 5x squared, which is 4x squared, and minus 15x. Okay, so multiplying, you're just using all the same rules. Remember, what it's telling you to do with the functions is to take the right-hand side of those function rules and then simplify that. So there's no extra x's that you're multiplying in. You're just taking that right-hand side. All right, and then there is some more that you get to do. I'm going to leave that f of x minus g of x. They've just changed our equations a little bit. Actually, no, they didn't. They're the same ones. All right, this one I'm going to do, though, and then I'm going to look a little bit at the dividing ones. We are going to be talking about what we're allowed to use with division. So if I have f of x squared, this is the same thing as f of x. We're going to use that. And that squared is attached to the brackets, and there's 2 of them. So it is the easiest is to do that. Don't distribute that squared with it. And then replace with your 2x plus 5. So this is 2x plus 5 times 2x plus 5. Do not just double everything or multiply it that way. You do have to FOIL or you have to use the area method. I am going to, since I did the area last time, I will do arrows this time. So 2x times 2x is 4x squared. 2x times 5 is plus 10x. 5 times 2x is plus 10x. I'm just going to put it in one row, even though it's easier if I have two rows. And 5 times 5 is plus 25. Now, I have like terms here. So this is going to be 4x squared plus 20x plus 25. We are going to be doing a whole bunch of those later on, and we're going to start recognizing those. But that will be when we start factoring and looking at stuff like that a little bit more. Now, when we are looking at the division one, we do have to be careful. We're going to rewrite it the same as we've been doing. G of x is 2x squared minus 3x. And it is over, f of x is 2x plus 5. Keep those in brackets. Now, we do have a rule. They will also often say that the bottom, they'll give you something extra that usually throws people off. They could say f of x does not equal 0, meaning I'm gonna force this problem not to cause me to divide by 0. The other thing that they could do is find the excluded values or say, what numbers can't we use with this? And that's where we're solving that bottom, to say what would cause that denominator to equal 0, which we're not allowed to do. So the only rule that we have in math right now with what we know is we can't divide by 0 because we don't know what's going to happen. It doesn't make sense. It's like saying I have 15 pieces of garlic chocolate and I'm going to give it to absolutely nobody. You don't know what I'm going to do with it. I might throw it away. I might keep it for myself. But I can't divvy it up amongst no people if I have it. If I divvy it up amongst one person, that means I keep it, but even I wouldn't be having it if I was a group of 0. So in any case, if I was trying to find excluded values, I would just take that denominator, so 2x plus 5, and I'd say equals 0. Where is this going to equal 0? You'd subtract 5, and you have 2x equals negative 5, and you have x equals negative 5 halves. So I cannot use, this is my excluded. But in all, my answer is I can't simplify this at all. I don't have anything that divides nicely into all of those terms. So my actual answer is just going to be 2x squared minus 3x over 2x plus 5. And I just say x not equal to negative 5 halves. That would be my formal answer. A lot of times they're just going to have you simplify it. All right, so you do the first one, looking with that. There are some practice with some evaluating. Multiple choice, so we get to say what the answer is. We're going to do some practice with this. So do these problems, check them out, and then check out the answer key when you have done them. And let me know if you have any questions.